Let's talk about partial fraction decomposition. In order to perform a partial fraction decomposition, we need to make sure that we have a proper rational function. A proper rational function is defined as a rational function whose degree of the denominator is greater than the degree of the numerator. Here are a couple examples of that. 4x plus 1 over x squared plus x. Degree 1 versus degree 2. The denominator has a bigger degree than the numerator. X plus 14 over x squared plus 7x plus 10. Again, x power 1, x power 2. The degree of the denominator is larger. 5x minus 2 over x plus 3 squared. Degree 1, this is going to end up being a degree 2, therefore the denominator has a higher degree. So what happens when the degree of the denominator is equal to or less than the degree of the numerator? Well, we're going to need to perform a long division. Let's go ahead and take a look at this improper rational function. As you can see, it's improper because the degree of the numerator 3 is larger than the degree of the denominator 2. So we go ahead and set up our long division. Now we just perform that long division. I want a value that multiplies by x squared to produce the 2x cubed. That would be 2x. That also multiplies by the negative 4x, which would produce negative 8x squared. We subtract both of these terms. That'll cancel out. That will turn positive and cancel out with the negative 8x squared as well. And the 1 will just drop down. Now here we stop because we won't have a term that'll multiply by x squared to give us the 1. So this is our remainder. Therefore, we rewrite our improper rational function as 2x plus the remainder 1 over x squared minus 4x, because remember, the 1 could not be divided out. This now is a proper rational function, and we could go ahead and integrate this if we needed to integrate this from the start. 2x would be easy to integrate. This would require us to just do a partial fraction decomposition. Let's go ahead and take a look at another example here. Again, we notice that this is an improper rational function because the degree of the numerator 4 is larger than the degree of the denominator 2. Therefore, we go ahead and set up our long division, which ends up giving us x squared with a remainder of 4x plus 2. Therefore, we'd rewrite this expression as this, and then we'd be able to integrate this using our partial fraction decomposition technique.